Hi, Marty Dwyer with Boat Anchor Audio. A little while ago, I got interested in multi-tone audio tests. I've never used them before, and frankly, I did not know all that much about them. So I thought I would look into it and see if it has some use. What I've found is, yes, it does have some use in some cases. In other cases, it's pretty close to useless. So what we have is a printed circuit board. It's a $30 special. I got it off from eBay. It's a TPA 3255 based audio board. And we're going to have two different power supplies powering this board. One's a lab quality linear supply. The other is an El Cheapo switching brick supply. Both of them put out 31.5 volts. So we want to have that even. But what I want to do is show you what multi-tone testing can do, why you'd want to use it, and what multi-tone testing cannot do, and why you probably ought to stay away from it. Anyway, without further ado, let's run a couple tests and see what we have here. Here's the board we're going to be testing. It's nothing fancy about it. It's just a generic Class D amplifier based on the TPA 3255. Got it off of eBay for about $30. We're going to be testing this board with two different power supplies. And this will enable us to do an A-B test. One test will be a benchmark. The other test would be a production test. So let's see what happens. Let's get started. Okay, this is going to be our first test. This will be used as our benchmark. Now, as mentioned previously, we have just one printed circuit board. What we're going to do is swap the power supplies. Now, this test is done with a lab quality linear power supply. Let's take a look at it and see what we have here. First of all, we have 32 tones spread across the spectrum from about 20 cycles to 20 kc. There are 32 tones, 32 different frequencies. The amplitudes of all the tones are the same. Now, what can we derive from this? First of all, this is a visual test. There's no numbers up here saying what the THD is, what the signal-to-noise ratio is, what the intermod is. It's strictly visual. Looking at it, along the top, we see the frequency response. It looks fairly good. We get up higher in frequency, it tends to peak a little bit. Now, Class D amplifiers, some of them are known to do that, especially with higher impedance speakers, such as an 8-ohm speaker may be a little more peaky than, say, a 4-ohm speaker. Right now I'm using a 8-ohm non-inductive resistor as a dummy load. But that gives you some idea of what their frequency response is, but we can't attach a number to it. Another thing we take a look at is a distortion-free range here. Starting up here at 0 dB, we can go down to, looks like about minus 93 dB. So along this range here, ignoring that little spike, along this range here, this range of frequencies, we have a distortion-free range of greater than minus 90 dB. Now that's pretty good for a $30 board. For a $3,000 amplifier, it may not be so good. Personally, I'd want my money cheerfully refunded. Now, let's see what we have down here. We've got a little spike here. It's, judging from its frequency, I would say it's an intermod, not power supply related. Little intermod there. Now, as we move along here, the intermod seems to be quite low. We start picking up some intermod, these little spikes here. They're intermod. They extend down into the noise. This is the noise level here. But as you can see, the noise, the intermod does have a tendency to go up with frequency. This is not unusual, especially with lower price amplifiers, where the noise level may increase as you go up in frequency. Some amplifiers, the noise level may increase as you go down in frequency. Again, we have to emphasize, I can't measure what that intermod is. I have no idea what it is. I only know that it's there. So there's two tests right there we can run. The frequency response and the intermod. Everything else is pretty much visual. Now, a visual test doesn't tell you very much, does it? Couldn't agree with you more. Now let's take a look at the same board. Our settings on the analyzer are going to be the same. The only difference is we're going to swap the power supplies. Okay, let's take a look at that. Here's the same board. It's set up the same way. The analyzer has the same configuration. The only thing that's changed is we've taken away the linear power supply and replaced it with a generic switching supply. The voltage output of both power supplies is the same. It's about 31.5 volts. Let's take a look, see what we've had here, and see what has changed just by swapping out the power supply. The first thing we notice is we're picking up a 60 cycle fundamental along with 120, 180. That's probably 240. It's hard to interpolate these log scales. But we're picking up that 60 cycle fundamental and a bunch of harmonics. Now, that is probably causing some intermod here. I suspect some of these harmonics, or perhaps even the fundamental, is beating against some frequency and causing some intermod. I believe that's intermod. I don't believe it's the power supply harmonic. I think that's intermod there. But looking along the bottom, there's one or two little spikes. As we go up higher in frequency, as mentioned previously, the noise level goes up. Excuse me. But it doesn't seem to go up as high as it did using the linear power supply. That's a curiosity. Also, the intermod up here does not seem to be as extensive as it was with the linear supply. Let's take a look at the distortion-free dynamic range. Before we had about roughly minus 93 dB distortion-free range. Now, ignoring the power supply fundamental and the harmonics and these little intermod spikes here, which I suspect are a function of the harmonics. In other words, if you did not have a switching supply with harmonics, if you had a good supply here, you probably would not get this. But just for sake of argument, let's just ignore this. And we see, oddly enough, the distortion-free range has increased from about 93 dB, minus 93 dB, to about minus 98 dB. Now, why did that happen? Remember, the only thing we changed was the power supply. That's a curiosity. I don't know why it happened. And that extends. This is your minus 90 dB here. And even up here at the very end of 20 kc, the distortion-free range on a worst-case basis is still minus 90 dB. That's not that bad. As mentioned previously, for a $3,000 amplifier, I'd probably want my money back. But this is not a $3,000 amplifier. We're talking right here a $30 board. So that's one test you can do if you want to test power supplies. Normally you would. Remember, we are pretending that this is a separate board, and we're going to compare it with our benchmark, and we're going to do that right now. Okay, what do we have here? Well, before we dive into this, let's play a game. Let's say you're making 50 boards, and they're going to sell for, say, $40 a piece, just to pull a number out of the air. They're whatever you want them to be, a Class D audio amp, a Class B audio amp, whatever. But it's some type of an audio amp. Now, you test your prototype. You've done a prototype. You've tested it thoroughly. Now, that takes time. With the QA403, it'll probably take 10 minutes, maybe 15 minutes to do all these tests. Some of these tests do take quite a bit of time, such as THD versus frequency, for example. It really takes some time to do it. Anyway, what we would do is test one board, and if it really looks good, we would use that as our benchmark. Now, we're going to pretend this is our benchmark. All the boards we make have to meet this benchmark. They have to look like it has good frequency response, because this board, which is our benchmark, has been tested for good frequency response. The intermod, the noise level, is acceptable. Okay, now we have another board here. Now, as I said, these are the same boards. We're just pretending that this is a separate board, but it's being powered by a different power supply. But let's take a look here. Now here's where you have to make a judgment call. If you test your boards and you get this result, and this is what you want, now what do you do? Here's where you got to make an arbitrary decision. Is this acceptable for, say, a $40 printed circuit board? These little spikes of Intermod down here? Or do you just blow the whistle and say, this is not going to cut the mustard, it's no good, we're going to have to find out what's going on here. Perhaps we have some bad parts or bad solder joints, whatever. But that is a judgment call. But that, in my opinion, is where multi-tone testing comes into its own, where you can test a lot of boards against a benchmark very quickly. As I mentioned, this thing, to test this thoroughly, might take 10 or 15 minutes to test your benchmark thoroughly. This might take 10 or 15 seconds to do a multi-tone test. It's only good for, in my opinion, pass-fail. You cannot break any of these numbers, any of these tests down into numbers. I can't tell you what the THD is. I can't tell you what the Intermod is. I can't tell you what the crosstalk is. I don't know. I don't know what the SNR is. You'd have to test it thoroughly as far as the QA403 goes. And to do a complete set of tests does take time. All right, there you've had a short video on multi-tone testing. We've given, in my opinion, what multi-tone testing is good for, what it's not so good for. Breaking it down very simply, multi-tone testing would not be very good. In fact, I think it's totally useless for testing a prototype, for example. You would have to do individual tests using, say, a Quantisylum 403 or an AP audio analyzer, something like that. Something where you can break your test down into numbers. Now, where multi-tone testing would be useful, in my opinion, is a production line, where you have a benchmark that has been thoroughly tested. Now you do a multi-tone test on your benchmark, and you compare all your production units with that multi-tone test result from the benchmark. Now, multi-tone testing with the QA403 takes about 15 seconds, whereas to thoroughly test an amplifier may take 10, 15 minutes. Because some of the tests, as I mentioned, are very time-consuming, such as THD versus frequency. But it's a test that has to be done at least for your benchmark. Now, if you're testing a $3,000 amplifier, naturally you will test it thoroughly, whether it takes 10 minutes, 15 minutes, or 20 minutes. But for something that may sell for, say, $40, you may do just a simple A/B testing with multi-tones. What your criteria is for pass-fail is up to you. Anyway, in my opinion, that's what multi-tone testing can do, what it's good for, what it's not so good for. Anyway, they're nothing but my opinions. If you have any comments, please leave them below. We'd be interested in looking at them. We'll talk to you later.